Hello friends, I hope everyone is doing well and enjoyed their days away from school. It is a beautiful Wednesday and I'm working on our videos for the week. So we talked about adding and subtracting radical expressions the last time we saw you in class. So today we are going to talk about multiplying radical expressions. And I actually think multiplying is easier than adding and subtracting, and I will show you why. Alright, so for example 1, we're going to look at multiplying the square root of 3 times the square root of 5. Now both 3 and 5 are prime numbers, so we can't do a factor tree and simplify those anymore. So we just multiply the two numbers together to get the square root of 15. And again, 15, if we do a factor tree, is just 3 and 5. So it is simplified as much as possible, so this is our answer. So that's it, my friends. If you multiply radical expressions, all you have to do is multiply numbers by numbers and then simplify to get your answer. So let's look at another example where we do have to do a little bit of simplifying. So if we had, let's look at example 2. If we had the square root of 6 times the square root of 15. Now I think it will be easier for us if we go ahead and do our factor trees on each of these numbers and put it all together underneath one radical. So I'm going to, I'm going to do the blues in red and the 6s in red and the 15 in green. So if we have our square root symbol, our radical, 6 breaks down to 2 times 3, and then 15 breaks down to 3 times, that's not right, I was about to write 15 again, 3 times 5. And again, if there's no index listed, it's a 2. So the name of the game is 2 of a kind. We're looking for 2 of a kind, and we can see that we have 2 3s here. Even though they came from two different numbers, we're multiplying 6 and 15 together, so we can pull those 2 3s out of the radical, and our friends left inside that don't have a pair are the 5 times 2, which gives us 10. Now, we could have done this. We could have multiplied 15 times 6 and done that underneath the radical. So let's do that. 15 times 6 would give me 90, square root of 90. So then we would have had to done 2 and 45, and 45 is 3 and 15, and 15 is 3 and 5. And look, 2 here, 2 here, 3 here, 3 here, 3 here, 3 here, 5 here, 5 here. So again, I think it's a little quicker to go ahead and simplify it before we multiply them together, because we're going to end up with the same thing at the end, which is 3 times the square root of 10. So let's try one more where we have to simplify, which is numbers. Alright, so let's get a little tricky here, and I'm going to do the cube root of 18 times the cube root of 6. And now we have a 3 as our index, so the name of the game is 3 of a kind. We're looking for 3 numbers that are alike. So I'm going to do the 18 in red. 18 gives me 2 and 9, and 9 gives me 3 and 3. 6 gives me 2 and 3. So now when I rewrite my radical, I have 2 times 3 times 3 from the 18 times 2 times 3 from the 6. And again, we have an index of 3, so the name of the game is 3 of a kind, so it looks like I've got 3 3s. So 3 can come out of the radical, and I'm left with 2 times 2 on the inside, which is 4. So 3 times the square root of 4. It's just that simple, my friends. This is pretty easy stuff. Alright, so now let's look at if we added some variables in. So I'm going to do the cube root of 18x cubed times the cube root of 72x to the 5th. Now 72 times 18 is going to get real big real fast. So again, I'm going to rewrite this out, and we're going to go ahead and do our factor trees before we combine them. So 18 is 2 and 9, and 9 is 3 and 3. So I'm going to go ahead and draw my radical over here. So we can do 2 times 3 times 3, and then we have 3 x's, so I'm going to write those out as 3 x's. And then we're going to do 72 in green. So 72 is 2 and 36, and 36 is 2 and 18, and 18 is 2 and 9, and 9 is 3 and 3. Alright, so then I'm going to do 2 times 2 times 2 times 3 times 3, and then I have 5 x's, so 1, 2, 3, 4, 5. Alright, remember our index is 3, so the name of the game is 3 of a kind. So I'm going to use the yellow, or maybe I'll use a highlighter. Let's try the highlighter and see what that looks like. So I'm going to use my yellow highlighter. Let's see. I've got 1, 2, 3 2's. So a 2 can come out. Ooh, I do that every single time, y'all. Someday I will remember. So we've got a 2 that can come out. All right. So now let's look at the 3's. I've got 1, 2, 3 3's. So we can multiply 3. We're going to multiply the things on the outside together that we pulled out. So 2 times 3. Now let's look at our x's. So there's quite a few of those. So we've got a set of 3's here, 3 x's here. So we can do 1x. And we're going to look for another set of 3's if we 3 x's if we can. And I think we can right here. So that gives me another x to bring out. And looks like I'm left with a 2, a 3, and 2 x's on the inside. So then I'm going to draw my radical with my index of 3. And we have 2 times 3 times x left on the inside. So now our last step is to simplify. So 2 times 3 on the outside gives me 6. We have 2 x's, so that gives me x squared. Then I've got my radical with my index of 3. 2 times 3 is 6. And we have x squared again left on the inside. So there we go with the answer to that example. Alright, so let's do another type of problem that we're going to look at today. So we are going to we're going to look at dividing when we have radicals for just a minute. We're not going to do very many of these. We're going to stay pretty basic. But what if we had 1 over the square root of 2? Now, in the rules of math, we do not like to have a square root or a radical in our denominator. So we have to do what we call rationalizing the denominator, or basically taking that radical away. So what we have to do in this situation is, just like with fractions where we can multiply something by like 3 over 3 if we needed to change the denominator, we can multiply things by radicals. So if we want to rationalize this denominator, we're going to take it and we're going to multiply it by radical 2 over radical 2. I kind of drew that backwards. And then we simplify. So on the top of our fraction, we're going to have 1 radical 2, or just radical 2. And on the bottom, we have radical 2 times radical 2, which is radical 4. And radical 4 simplifies to be 2. So that is how we rationalize the denominator. So let's do another one of those. Let's try the square root of 2 over the square root of 15. Just like we did in our first example, we're going to multiply it by a fraction that looks like the square root of 15 over the square root of 15. So we're going to we multiply numbers by numbers, so we have the square root of 30 over positive 15. Now, we've got to do a factor tree. I told you we got to get really good at factor trees. So let's look at 30. 30 gives me 2 and 15. 15 gives me 3 and 5. We don't have anything we can simplify, so we are done there as well. So let's try one more with a variable in it. I'm going to go red on this one. So what if I had the square root of 8x over square root of 3xy. All right. So once again, we're going to multiply by the denominator so we can rationalize it. So we end up with 3xy on the bottom because if they're the exact same, so we're basically doubling it, so we have two of them. That takes away the radical. So on top, we multiply our numbers by our numbers to get 8 times 3 is 24. We have x times x, so that gives me x squared, and then we have a y. Now we need to simplify. I'm going to do my factor tree on top. 24 is 2 and 12. 12 is 2 and 6. 6 is 2 and 3. So it looks like I have a pair of 2's that can come out. So I have 2. Looks like we have a set of 2 x's here, so one x can come out. And then what's left inside is that 6, this 2 times 3 right here that we had left over, 6 and a y all over 3xy. Now we have one last step to do, because if you can see right here on top we have an x both places. And x divided by x cancels out, so I'm going to move over here to the left to write my answer. I have 2 radical 6y over 3y left. Now we can't cancel those y's out because one is inside of a radical and the one in the denominator is not, so we can't cancel those out. We can only cancel things out if both of the radicals are the same, or if the things outside the radical can be divided by each other or can cancel out. Alright, so you have 9 problems to do today. You're going to do 8 of them, and then in example 6, the last problem, problem C, is bonus because it's a cube root. So if you can figure out how to do a cube root and rationalize the denominator, we'll give you some extra bonus points. As always, Ms. Tucker and I are here to answer any questions. And watch this video as many times as you need to while you work on your assignment. And let us know if you need anything. Have a good day.